Piecewise defined functions. Piecewise defined function is a function where different rules are used for getting output values on different parts of the domain. For example, this given function behaves differently when x is less than or equal to 0, behaves differently when x is between 0 and 1, and behaves differently when x is greater than 1. Be careful if there's an equal sign or not, because that would change how our graph is going to look when we are graphing. If there is no equal sign at a particular x value, we will have a hole on the graph. Domain of piecewise defined function is the union of domains of each pieces. Here's an example. Given f of x as a piecewise function, and we want to evaluate this piecewise function at -2, 3, -4, and 1. Let's look at evaluating at -2. So when x is f of -2, we're given when x is equal to -2, we will be using this rule. So f of -2 is going to equal negative of the -2, which is going to be +2, because that's where we have the equal sign. F of 3, for f of 3, we will be looking at this region. So we're going to replace x by 3 in here. That would be 3 squared minus 7 times 3, 9 minus 21, which is going to be -12. F of -4, for this one, for part C, we're going to look at the first rule, because -4 is less than -2. So we're going to replace x by -4 and simplify. -12 minus 2 is -14. Next, we are looking for f of 1. So for f of 1, again, we're going to be looking at the very last rule, because that's where we have the equal sign. In the middle rule, we don't have the equal sign, so we'll go with the very last rule. So when x is 1, I would have 1 minus 7 times 1, which is 1 minus 7. That's -6. Now let's look at another example of evaluating a piecewise defined function. First of all, we're looking for f of -1. F of -1 is going to be, for -1, we're going to look in this region. So that's going to equal to 2. For finding f of 1, we will be looking at the rule here, because 1 lies in between. So 2 minus 1, replace x by 1. 2 minus 1 is 1. To evaluate f of 0, we're going to look at the second rule again, because that's where we have the equal sign. In the first rule, we don't have the equal sign, so second rule. And we're going to replace x by 0, which is going to equal 2 minus 0, which is 0. And to evaluate f of 3, we will be looking at the very last rule, because that's where x equals 3 lies in that part of the domain. So that would be 3 plus 1, which is 4. Next, we're going to look at graphing a piecewise defined function. F of x is x squared plus 1 if x is less than 0, and it's x minus 1 for x greater than or equal to 0. Keep in mind, I have an equal sign here, and I don't have an equal sign in the first function. So for x less than 0, I do have a parabola which is shifted 1 unit up. So I'm going to start plugging in the numbers in the parabola to figure out where to plot the graph. So when x is 0, y is going to be 1, and I will have a hole in there. When x is -1, y would be equal to 2. When x is -2, y would be equal to 5. And that's how my parabola is going to look like on the left hand side. For x greater than or equal to 0, my graph behaves like a line, y equals x minus 1. So for x less than 0, I had y equals x squared plus 1. For x greater than or equal to 0, y equals x minus 1. So when x is 0, y would be equal to -1. When x is 1, y will be 0. When x is 2, y will be 1, and so on. So this is how my line will look like. It might be helpful to make it a different color to show that this is separate line, separate graph. Make sure you show the holes clearly in your graph. Next example, we're going to be graphing f of x equals 3x plus 2 if x is less than negative 2. So look at to the left of negative 2, my graph is going to be, it's going to be a line 3x plus 2. So when x is negative 2, I'm going to plug negative 2 in here to figure out the y value. 3 times negative 2 is negative 6. Negative 6 plus 4 is, negative 6 plus 2 is negative 4. So when x is negative 2, y is negative 4. When x is negative 2, y is negative 4, and I'm going to have a hole at that point. When x is negative 3, y would be negative 9 plus 2 is negative 7. When x is negative 3, y would be negative 7, and so on. Should touch that point. So this is how my graph is going to, again, missed it. Negative 3, y is negative 7. Okay, there we go. Now between negative 2 and 1, my graph behaves like negative x. So there is an equal sign here. So I will have no hole on this side, but there's no equal sign towards 1, or at x equals 1, I will have a hole there. So when x is negative 2, negative x will be positive 2. So y will be positive 2 when x is negative 2, which is happening right here, and no hole there. When x is negative 1, y would be positive 1. When x is 0, y will be 0. When x is 1, y would be negative 1. And I will have a hole at this point. So there is going to be a hole at x equals 1. And I do have a little bit of piece of the graph here. For x greater than or equal to 1, I have a parabola which is shifted 2 units down. So when, again, to figure out the points, I'm just going to start plugging in x as 1, 2, 3 in here to mark my points. So when x is 1, y is going to be negative 1, and there's no, there is going to be, the hole is going to be covered there. So for the last graph, my hole is going to cover, my last graph is going to cover the hole that I have here. And when x is 2, y would be 2 squared. 4 minus 2 is 2. When x is 2, y would be 2. And it's going to be a parabola. When x is 3, 3 squared is 9. 9 minus 2 is 7. Y would be 7. In that case, when x is 3, y is going to be 7. So this is how my graph is going to look like. It's going to be a parabola here. Let's make it a nicer parabola. Right. Now next one, it doesn't look like a parabola right now because you don't see much curve to it, but do make it like a little parabola here. 2 and 2 and 3 and 7. All right, so that's how my graph looks like. And there's only hole at this point. The other hole was covered. Now for next problem, pause for a minute, go ahead and give it a try, and come back and check your answer. We do have a straight line for x less than negative 2. Start plugging in the values. Plug in the negative 2 in here. When we plug in as x is negative 2, y turns out to be 1. And plug negative 3, negative 4, and see where your line is headed. In between, I have an absolute value function, which is reflected over x-axis, and it's shifted up 5 units. So start by plugging in negative 2 into this function, and then plug in negative 1, 0, and 1, and 2. To get this graph, there is a hole at this point here. And then to get the last graph again, we'll start plugging in the values 3 and above, and we'll be able to see our line going upwards to the right of 3. That's all for piecewise defined functions.